Lesson 13.1. Use trigonometry with right triangles. If you have a right triangle, there are 6 ratios of sides that are always constant. This comes from the fact that if you have angles don't change, the triangles will be similar, and similar triangles have constant proportional side lengths. Alright, so if we pick an angle, that symbol is called theta. Use that to represent our angle. We have the opposite side, opposite it. We have the adjacent side, which is the leg touching the angle, and the hypotenuse. Sine of theta is opposite over hypotenuse. Cosecant of theta is hypotenuse over opposite. So these are abbreviations. They're not sin. It is sine, S-I-N-E. This is cosecant. This is cosine. It's adjacent over hypotenuse. Secant. Hypotenuse over adjacent. We have tangent, so opposite over adjacent, and cotangent is adjacent over opposite. Now, notice a few things. They always are followed by the angle. It's always sine of the angle, cosine of the angle, tangent of the angle. So there always must be an angle after it because we have to know which angle we're talking about in the triangle. Is it the one down there or the one up there? We don't know, so that's why we have to specify which angle, because that changes which side's opposite and which side's adjacent. And the way I have them, the functions opposite each other are reciprocals of each other. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. Way to remember it is SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then the other 3 are reciprocals. And for the reciprocals, the cos do not go together. It's always a co and something else. Sine and cosecant, cosine and secant, tangent and cotangent. So let's evaluate the 6 trigonometric functions of the angle theta. If you're curious, that is spelled T-H-E-T-A. Greek letter. Alright, well, the first thing I need to know is what I have. So I have that side is the opposite. That side is the adjacent. I'm missing the hypotenuse, so I need to find the hypotenuse. I could use the Pythagorean theorem. So I can say 3 squared plus 4 squared would be my hypotenuse squared, which makes my hypotenuse 5. And then it's just fill in the formulas. Sine is opposite over hypotenuse, so that'd be 3 over 5. Cosecant is hypotenuse over opposite, so that'd be 5 over 3. See the reciprocals? Cosine is adjacent over hypotenuse, or 4 over 5. Secant is hypotenuse over adjacent, or 5 over 4. Tangent is opposite over adjacent, which is 3 over 4. And cotangent is adjacent over opposite, which is 4 over 3. Let's try it again. This time our angle is up here. So if I go there, the 15 is the opposite, the 17 is the hypotenuse. We don't know the adjacent, so we should find the adjacent. Use the Pythagorean theorem. So I can say the adjacent squared plus 15 squared equals our 17 squared. So our adjacent is 8. And then fill in the formulas. Sine is opposite over hypotenuse, so 15 over 17. Cosecant's hypotenuse over opposite, or 17 over 15. Cosine is adjacent over hypotenuse, or 8 over 17. Secant's hypotenuse over adjacent, or 17 over 8. Tangent's opposite over adjacent, or 15 over 8. Cotangent's reciprocal adjacent over opposite, or 8 over 15. Let's try another one. In a right triangle, theta is an acute angle and cosine of theta is 7 over 10. What is sine of theta? Well, let's start by drawing the triangle and picking one of the acute angles for theta. So there's my triangle, just some random triangle. I picked an angle for theta. All right, cosine is adjacent over hypotenuse. So I made the adjacent side here 7 and the hypotenuse 10. Use the Pythagorean theorem to find the opposite. So I can say 7 squared plus the opposite squared is 10 squared, and you end up with a square root of 51 for the opposite. So now we just need to find sine. Well, sine is opposite over hypotenuse. So that'd be square root of 51 over 10. Yes, we would like exact answers if possible. That means in radical form, not rounded decimals.